All right, so we're going to take a little break from our transformers here for a while. We're going to get into here on lesson 226, generators, transfer switches, and emergency systems. I will tell you the IEC textbook has you read a couple chapters in your electrical systems textbook, and it also refers you to read actually some code or portions of some code articles. I do recommend you do that, and I actually pulled some snippets from the code. I think they do a really nice job with some of these definitions and descriptions on the various system types. So anyway, make sure you're doing all your reading on this one. This is going to be a very fact-based chapter, not really a lot of math. It's more code references, information, things like that. So jumping right in here. Questions to consider when looking at generators, and most of this stuff is going to be decided upon by the engineer or design professionals, but is the unit going to be installed indoors or outdoors? What type of enclosure do you need? What will the fuel source be? Your main ones are diesel, propane, or natural gas. And then here's kind of the important part, I think, is the unit being provided for standby power as addressed in NEC 702? Is it a legally required standby system as addressed in Article 701? Or is it an emergency system as addressed in Article 700? Great questions. And we obviously they're a little different because we have three separate articles to deal with each. So let's try to put some words to this, some definitions of this. So this comes right out of the NEC Article 700. In this case, we'll start with emergency systems. Informational note 700.2. Emergency systems are generally installed in places of assembly where artificial illumination is required for safe exiting and for panic control in buildings subject to occupancy by large numbers of persons. So really, to be very specific, we're talking about emergency lighting in this case. So, and there's some other minor systems that might fall in there, but emergency lighting, are we using a generator for our emergency lighting? Not as common as the battery powered lights that we typically see, the bug eyes, the battery powered exit signs and everything. But this is an option. I'm sure, if you haven't seen this yet, you will at some point. It's certainly a valid option. But if we're talking about emergency systems, in other words, emergency lighting generally, Article 700. I apologize, I should say Article 701 up there, but Article 701, legally required standby systems. So again, informational note tells us that legally required standby systems are generally installed to serve loads such as heating and refrigeration systems, communication systems, ventilation and smoke removal systems, sewage disposal, lighting systems, and industrial processes that, when stopped during any interruption of normal electric supply, could create hazards or hamper rescue of firefighting operations. So, think about life safety and health. Is this going to majorly impact safety and health if this equipment stops? If so, odds are it could fall into a legally required standby system. And then last but not least, Article 702, informational note for the optional standby systems, typically installed to provide an alternate source of electric power for such facilities as industrial and commercial buildings, farms, and residences, and to serve loads such as heating and refrigeration systems, data processing, so on and so forth, where, hey, it's an issue, it's a pain if this stuff stops working in a power outage, but it's not life safety, it's not hazardous to safety and health. It might be financially disastrous, but that is not a legally required standby system. So those are your kind of three broad categories to be aware of. Read through the code articles that the textbook instructs you to. Again, that's where those three pieces come from, and there's a lot of other good information, so make sure you read that. But we'll just hit on some general things here. Large internal combustion engines and connected alternator units require efficient cooling systems. And here again, you are not going to be tasked with selecting and designing and coming up with this. That's the generator manufacturer and supplier. That's the design professional. But we need to be aware of such things anyway. So Article 445 addresses install of generators in general, and Article 250, of course, we know addresses grounding. Article 700 is emergency standby. 701, legally required standby. 702, optional standby, as we just said. Electrical connection to generators may be provided through a transfer switch and or other accessories. Almost always it's a transfer switch, and we'll talk a little bit more about those here in a moment. All AC circuits from a generator must include a circuit breaker or fuse protection. Generally, I'm talking sort of larger commercial generators, you're going to use the generator just to power an electrical panel full of breakers as it normally would be. Permanently installed AC generator is considered to be a separately derived system when the ground conductor is bonded to the generator frame. So in this case, just like on a transformer, we don't have any conductors that are common other than your grounding conductor, which gives us a separately derived system. A generator can and usually will be the same situation. And since it is a separate, or if it is a separately derived system, and since generally it is, we need to bond our neutral and ground for a separately derived system. No different for this generator. Grounding requirements for separately derived systems are in 250.30. Once again, most installations require the grounded conductor or neutral to be grounded. When with the install of a system bonding jumper, the system grounding conductor is connected to the equipment grounding connector on the alternator. So essentially they're telling us generally it'll be a separately derived system. Bond your ground and neutral on the load side of the generator. Transfer switches are used to protect critical electrical loads against loss of power. If you haven't dealt with transfer switches, we're going to dive into them a little bit. If you have, this will probably be old information, but a transfer switch is connected to both the normal and emergency sources and supplies the load with power from one of these two sources. In the event that power is lost from the normal source, the transfer switch transfers the load to the secondary source. Here we have some images here, right? So and these are manual transfer switches. They can be automatic as well. So here we have both manual transfer switches, but you're going to see here we're going to have essentially line 1 coming in, line 2 coming in, and then we have load going out in the middle. Same case up here. So depending, sort of this center is our common. I mean, it's essentially a three-way switch at this point, right? We have so this would be our load here. This is always connected. If we flip the switch up, it makes the connection here and here. And it makes the connection here and here. If we flip it down, it makes the connection here and here, here and here. So we'd have emergency power from the generator coming into one of these. We'd have line utility power coming into the other. So if utility power goes out, this would be connected. We come here and flip the switch and now make this connection instead. So now generator powers, load receives power. You can see you can never have them both connected at the same time. In this case, this one's the same exact scenario, just a little, in fact, it looks like it's just NEMA 3R versus NEMA 1, indoor versus outdoor. Here we see automatic transfer switch, same principle. This just has some circuitry to automatically detect that loss of power. And this one has some nice indicators to show what's energized and what's running and what's connected. But same principle, except in this case there's not a manual switch to throw. It has some circuitry to do that automatically. Here we're going to talk about the bypass isolation switch, which is designed for applications where maintenance, inspection, and testing must be performed while maintaining continuous power to the load. So imagine a legally required life safety system. We need to do some kind of testing or maintenance. We don't want to have to turn this off. So unlike traditional open transition switches that provide a break before make operation, the closed transition soft load switch allows two power sources, usually the utility and generator, set to be paralleled indefinitely. So in other words, in this case, we can actually throw that switch without killing power to the load. And then just to sort of wrap here, a maintenance bypass switch provides a simple and effective means for bypassing uninterruptible power supplies while maintaining continuity of power to critical computer loads. So sort of one last piece. We don't have much in the slide here, but again, make sure you do your reading. But uninterruptible power supply, in other words, known as a UPS system. We didn't mention it here in this video yet, but with the generator, you're going to have a delay before the generator power kicks in. That's where your UPS system comes in. That'll fill that lag between when utility power is lost and generator power picks up. that's going to use a series of batteries to ensure that power supply, as the name implies, is interrupted. So anyway, once again, sort of to wrap up, make sure you guys check out everything they ask you to read in the beginning of this chapter. There's a little bit in the electrical systems book. There's a little bit in your IEC textbook. And then, of course, check out those code points that they ask you to read as well.